Hello. In our last video lecture, we had seen shear force and bending moment diagram introduction. In that lecture, we had seen what is beam, types of supports and types of loading. Now, today we will see what is shear force, bending moment, what is shear force diagram, what is bending moment diagram and what is point of control picture. So first, we will see what is shear force. The shear force at the cross section of a beam is defined as the algebraic sum of all the unbalanced vertical forces either left or right side of the section. So this is summation of vertical force at left side of the section or summation of vertical force at right side of the section. So let's see by example. Consider this as a simply supported beam carrying point load. So let's take section here XX. So shear force for that section XX is either we have choice to take vertical summation of vertical forces either left or right. So see from that section this is right side and this is left side, and see here in left side there is only one force and in right side there are two forces this. So right side forces we need to take summation of that forces. See summation of fy are this and right side, and for that left side summation of this force, this is fy and this is left side. So what is sign convention of for that shear force? So see sign convention. Positive shear force is this is XX section and see this is positive shear force. That means while calculation of this shear force diagram from left side, see this is, and at this is section XX. Take here as like this. This is shear V. And this is the upper. And this is positive. When we take this is left. This is detail of this. Detail A. This is detail A. And see this side. Let's take this as detail B. And draw detail B. Here this is Fy, this is also Fy, and here this is V, and this is positive. We need to calculate this V. And how to calculate this detail A V? Simply summation of Fy at left side. And how to calculate this V? Simply summation of Fy at right side. And this upward direction is positive and downward direction is negative, simply by Cartesian coordinate. Next is negative sign convention. Negative shear force. This is XX. This is upward, and this is downward. So for that beam, if you take this V as upward, then this is negative sign convention, and this V as downward, then this is negative sign convention. Because see, why it is positive? Because we need to balance it. See, this is upward and this is downward. This is downward and this is upward. So, and this is represented by like this also. Positive shear force. And this is represented by like this also, negative shear force. So see, by definition, an upward force to the left of section or downward force to the right of section will be considered as positive shear force, as shown in this. And when the force is downward to the left side of the section and upward to the right side of the section will be considered as negative shear force. Now, next is bending moment. So, see, definition of bending moment. The bending moment at any cross section of the beam is defined as the algebraic sum of moment of all the forces either left or right of the section. Summation of moment of either all the forces either left or summation of moment of all the forces either right. See, difference between shear force and bending moment. In shear force, we only take vertical summation of vertical forces either left or right. Here, moment word is new, and moment we all know. Moment is force into F into E, force into perpendicular distance or lever arm. So we will see similar example for that bending moment. We take similar beam as we considered previously. This is W, same section XX, but here we calculate moment. Let's consider moment at x location. And so see here, bending moment is summation of moment of forces either left. So here this is left side and this is right side. So left side moment of this force is this force multiplied by this distance, something distance x. And second, either we consider left side or right side. When we consider right side for that moment at x location bending moment, so right side, see there are two forces in right side. One is this and one is this. And for that this force, moment is this force multiplied by this distance. Let us assume this as x1 and plus summation, see this summation, this force multiplied by this distance, something s2. And now we will see what is sign convention for that bending moment, because see, when we consider moment for this force and moment for this force, there is no similarity in sign. Signs, both signs are different. For this force sign is different and for this force sign is different, because direction is different. See, this is vertical, this is downward, and acts like anti-clockwise. See, this acts like anti-clockwise and this acts like clockwise. So see, sign convention. First sign convention is sagging bending moment sign convention. See, when clockwise movement on the left of the section or anti-clockwise movement on the right of the section is considered as positive bending moment. That means upward force on the either side of the section of beams tends to bend the beam so that it produce concavity above the center line is called as sagging. See, I explain you. This is XX section, and due to loading this section bends, and this bends downward because of this loading is vertically downward. So this is deflection of that beam, and this is clockwise movement on left side of the section and anti-clockwise movement on right side of the section. This is positive movement. That means sagging bending movement or sagging bending movement. And now read the definition. When clockwise movement on the left of the section, see this is clockwise, and anti-clockwise movement on the right side of the section is considered as positive bending movement or sagging bending movement. And see, upward force on either side of the section of beams tends to bend the beam so that it produces concavity above the center line of that section. That means center line of this beam is like this, and it produces concavity. See, this is concavity. It produces concavity above the center line of that section. Now next is Hogging bending moment, that means negative bending moment. So for hogging bending moment, similar section XX, only it is like this. This is left side, this is right side, this is on left side anti-clockwise movement and on right side clockwise movement. Anti-clockwise, clockwise. Now read definition. When the anti-clockwise movement on the left of the section or clockwise movement on the right of the section is considered as negative bending moment or hogging bending moment. Downward force on either side of the section of beam tends to bend the beam so that it produces concavity above the center line is called as. So here center line is somewhere like this and this produce concavity, and here center line is somewhere like this and it produce concavity. So here below center line concavity, and here above center line concavity occurs. This can be represented by like this also. Positive bending moment or negative bending moment. For calculation of bending moment and shear force of any particular beam, we need to consider either positive bending moment sign convention or negative bending moment sign convention. Any one sign convention we need to consider. So next is definition of shear force diagram. So the shear force obtained analytically are representing by plotting shear force as ordinate y-axis against the position of cross section as epsica x-axis. The diagram obtained is called as shear force diagram. See how we draw shear force diagram. See similar example. Consider this as a beam carrying point load as W, and here this is W by 2 and this is minus W by 2, and shear force diagram is this. This is upward reaction, so this shear force goes upward. Now there is no loading, so shear force is straight line. So here downward, so it is downward. This W is greater than W by 2, so it is downward, minus W by 2, so it is straight, and again upward W by 2. So this is positive, this is negative, this is W by 2, this is W by 2. Now read definition. What is shear force diagram? The shear force obtained analytically. This is obtained analytically. These values are obtained analytically. And this is graphical representation. Are representing by plotting shear force as ordinate y-axis. See this as y-axis against the position of cross section as epsica x-axis. See this as x-axis. Position of cross section is this line. The diagram obtained is called as shear force diagram. Now next is bending moment diagram. See, for that beam, bending moment diagram is WL by 4. Now, definition of bending moment diagram is the bending moment often analytically are represented by plotting bending moment as ordinate y-axis. See, this is representing at y-axis and against the position of cross section as abscissa x-axis. This cross section position is x-axis. So this is bending moment diagram. We will see this shear force and bending moment values calculation in further classes. So this bending moment is very important for our design point of view. We need to calculate this bending moment for calculation of any element, for design of any element, beam, column, footing, etc. Now next is point of contrafacture. This point of contrafacture also known as point of inflection. Inflection. So first I need to draw beam and let us consider overhanging beam. With which carrying uniformly distributed load. So when I draw bending moment of this beam, so how this bending moment comes? See here I have drawn bending moment. See bending moment. Due to this uniformly distributed load, this bending moment shape is parabolic curve like this. So here see at that point, see at this point bending moment is 0. Here bending moment is positive, here negative. So why here bending moment is 0 and why this bending moment change sign from positive to negative, and what is point of contrafacture? So first read point of contrafacture definition. It is the point at which bending moment diagram changes its sign. Generally, bending moment at this point is equal to 0. It is definitely occurs in case of overhanging beam with supports within supports. Point of contrafacture is calculated by equating expression of bending moment at section XX as shown in this figure to 0. So this is point of contrafacture, and this is in overhanging beam and between both of these two supports, and this distance x distance we calculate by taking at this point, at this section xx, bending moment equal to 0. See, it is definitely occurs in case of overhanging within supports. Point of counterfacture is calculated by equating expression of bending moment equal to 0. So what we had seen in this lecture, first we had seen shear force. In that we had seen sign convention for that shear force. This is positive shear, this is negative shear. And what is shear force? It is either summation of left side forces for any section and summation of right side vertical forces for any section. Second, we had seen bending moment. Bending moment is summation of movement of all the forces, either left or right. This is sagging bending moment. See, shape of this sagging bending moment. This is like smiley shape. This left side is clockwise and right side is anti-clockwise. And hogging bending moment. This left side is anti-clockwise, right side is clockwise. See, see forces. Forces behavior are also very important. This force pushes this beam like this, and this force pushes this beam like this. That means this beam bends upwards and forms concavity above its center line. This is shear force diagram. This is bending moment diagram, and this is point of contrafacture or inflection, point of inflection. Thank you very much.